Good day. Our topic today is optical properties. So first, let's have a definition of terms. We start with optics. It is a branch of physics that deals with the behavior of light and other forms of electromagnetic radiation. So next we have optical, operating in or employing in the visible part of the electromagnetic spectrum. And then we have optical properties, are those material properties resulting from physical phenomena occurring when any form of light interacts with the material under consideration. And now, let's talk about reflection, refraction, and absorption. A simple picture starts by considering a ray of an electromagnetic wave of a single frequency entering a medium from vacuum. This could be reflected, transmitted, or absorbed. Reflection is the process by which light is bounced off of a surface. It can be a specular reflection, which is when light is reflected at a single angle, or diffuse reflection, which is when light is reflected in all directions. The amount of light that's reflected depends on properties of the surface. Refraction. When light travels from one medium to another, its speed changes and its direction changes as well. When a beam of light crosses the interface between two different media, the different physical properties of this media will cause the light waves to travel at different propagation velocities in each medium. Color. Color is essentially of a beam of light composed of irregularly distributed energy emitted at different wavelengths. Depending on the type of illumination, the same material can show different light qualities and produce different sensations. The color perceived when the eye views a food related to the following factors: the spectral composition of the light source, the chemical and physical characteristic of the food. Visual measurement of color entails comparing the color problem with reference colors available in printed charts under well-defined and favorable conditions for good, reproducible comparison. As we can see the diagram, we have a different visual measurement and with a different color. So if the ends of the spectrums are bent around, a color wheel is formed. There are several systems of colors analysis have been created. The most used are the CIE, Mansell, Hunter, and Lavivant systems. So this is the CIE system. In the CIE system, spectral curves indicate how the eye of normal observers responds to various spectral light types in the visible portion of the spectrum. The system is based on the fact that any color can be matched as a suitable mixture of red, green, and blue. These primary combinations are called tristimulus values of color. A certain color can be defined by chromacity coordinates x and y, and by the luminous transmittance or lightness. A chromacity diagram defines the different color points that define the standard color of a food. Next, we have the Mansell system. In the Mansell system, all colors are described by three attributes: hue or type of color, lightness relative to the proportion of light emitted, and saturation or purity, associated with clear to dark perception. The hue scale is based on 10 hues distributed on a circumference scaled 1 to 10. The lightness ranges from black to white 0 to 10 and is distributed on a perpendicular line. The purity is of irregular length beginning with 0 for the central gray to the limit of purity obtained by available pigments in the Mansell Book of Color. A Mansell colorimeter consists of a circular rotating platform where several colored discs are mixed in different proportions to provide a range of shades to match the color of a certain food product. It is widely used in the food industry for quality control of a number of a solid product like tomatoes, fruits, and peanut butter.
Lavivant system. The Lavivant system is a standard method generally used to determine the color of vegetable oils. It involves visual comparisons of light transmitted through a glass cuvette using color filters. Vegetable oils are usually expressed in terms of red to yellow. The Lavivant index can also be used to measure color in wines and juices. Color can be measured instrumentally with colorimeters, which may be broadly classified as tri-stimulus colorimeters and spectrophotometers. The difference between spectrophotometers and colorimeters is that the former measures intensity of light through the completely visible spectrum, and colorimeters are designed to measure only some parameters related to sensory color. Colorimeters are very useful in the qualitative control of foods and give results normally correlated with visual measurements. Gloss. It is a name given to a light specularly reflected from a plane smooth surface. It can be defined by a goniopotometric curve, which represents the intensity of light reflected at the surface at different angles of incidence and viewing. Gloss meters measure intensity of light reflected at 3 angles of incidence and reflection, and normally gives a result in the form of indices, obtained by comparing the sample reflectance to that of a highly reflective flat glass, used as calibration standard. These indices are easy to interpret, in contrast to more difficult goniopotometric curves used in the past for classification. Glossiness of a product is a property of the smoothness of its surface. When this characteristic is desired, manufacturers try to improve it, as in the case of fruits covered with wax to make them more visually appealing. Translucency. It is defined using an opaque to transparent scale. In liquid foods, light passing through changes its paths randomly. In other words, is scattered when interacting with suspended particles. Although light can be transmitted or reflected, the human eye only experiences translucency as a sensory attribute distinct from color. Many food products, such as cloudy fruit and vegetable juices, are neither fully opaque nor fully transparent, but are translucent. Translucency can be the measurement of the reflection of a thin sample against both a white and black background. From these measurements, the value of reflection from an opaque layer is calculated as a ratio between absorption and scattering to measure scattered light. Translucency is also worth consideration in some liquid foods, such as fruit juices. Its measurement can be determined by considering the contributions of both absorbed and scattered light when traversing with this product. Applications. Optical properties can be used to perform quality control and continuous inspection during processing operations. Major requirements for a quality control system are ease of calibration and use, stability, precision, speed, cheapness, and industry-wide applicability. A complete color description requires the use of 3 dimensions, and a control automatic system may be based on this complete specification. Specifications may be set to provide an idea of fruit ripeness, milk or cream discoloration during sterilization, degree of roasting of coffee grains, or browning of apple slices during storage. Continuous color measurements are used in tasks involving color sorting or electronic sorting by using inline systems. Color sorting is used for a very wide range of food materials in screening defects. Visible, infrared, and ultraviolet laser beams can provide continuous inspection through scanning of product size, symmetry, damage, irregular shape, fill level, and label placement by adding automatic software in connection with mechanical devices.